Hello everyone, welcome back to the session, and today we are doing Algebra 101 Theory of Equations. So let's start with the first idea of theory of equation. And when we talk of equations, we have to understand that the entire algebra comprises of equations of degree 1, degree 2, degree 3 and so on and so forth. Now specifically speaking, degree 1 equations are called linear equations. Degree 2, I am pretty sure that you guys would know, they are quadratic equations. Degree 3 are your cubic equations. Now typically CAT only go as far as cubic equation is concerned. Anything beyond order 3 is a little too much for a test of 40 minutes. Okay, so the quantitative ability section these days, they're testing you for 40 minutes. It will not be very, CAT in general does not ask such questions, but you get the idea, right? So anything beyond degree 3 is practically not coming in your exams. Okay, having said that, obviously because this is the first lecture, I'm going to start off with the linear equations, and please pay this thing, pay attention to this thing, that when we talk about linear equation, I'm not going to teach you how to solve linear equations, how to frame simultaneous equations. Rather, what I'm going to do is I'm going to elaborate everything in a graphical method. The graphical way will make things much more easier for you to understand. So the topic right now is linear equations. And a general linear equation can be written as ax plus by is equal to c. Now please don't worry, I'll explain everything what exactly this ax, by and c represents. Effectively, this is a equation of a line segment. Okay, now if I consider this to be my axis, okay, obviously this is my x-axis and this is my y-axis. Okay, now ax plus by plus c, if you just realize that if you substitute, because why do we substitute values for x and y? Because x and y are variables. So if you substitute 0 into this equation, by will become c, or y will become, or the value of y will become c by b. So I can get a point in the y-axis somewhere which can be written as this. Okay, that is basically the significance of c, because in your junior classes you may have heard that this represent the intercept. Now I am just explaining things, not going too back. Similarly, when you substitute 0 for this one, you will get a point somewhere over there which is c by a. Now obviously your task is to join them in with freehand. Okay, now I'm not very good with freehand this thing. So when you do that, this line that you are getting over there, okay, and this is a line, if you can just pay some attention, this line is the line ax plus by is equal to c. Now can you realize there are a few things in this line? We are going to, first of all, this is a decreasing line. Now just realize why is it decreasing? Because it has got a negative slope. Now please don't worry, there are going to be a bit of jargon because obviously we are studying algebra. So slope and all, right now I'm not going to give you the exact definition of slope, but slope you can understand. The steepness, okay, there are multiple definitions for a slope, but if you just realize the slope of this one is going to be negative. Okay, or in other words, you can also realize as x increases, typically you will see y will decrease. As x keeps on increasing, y will keep on decreasing. So when that kind of a situation happen, when I am increasing one of the variables, it can be even x. So if in the reverse order, if I am decreasing x, you will continuously see that y gets increased. So because there is this type of a peculiarity that is happening, we call it a decreasing line. Okay, this is going to be very important for when we will study the solutions or the rule for solutions. Okay, and that too typically integer solutions I'm talking about. All right, so I hope you have understood this idea. Now let's work around with some general cases. For example, let us say I have an equation a1x plus b1y is equal to c1. This is one of the lines, and I have another this thing a2x plus b2y is equal to c2. Now there are a few ideas that are floating around in books in general that I have to share with you, and it is important for CAT also. So we are looking for rules for solutions. Okay, now what exactly do you mean by a solution? For any equation ax plus by that is equals to c, if you substitute a solution, and solution obviously will occur in pair of x and y, so the solution when you substitute into that equation will result in making this equation equals to 0. Solutions are also called zeros of an equation, but that is again going a little too far ahead in this course. Right now we are just discussing about the solutions of linear equations in general. Okay, so suppose I have this equation, and obviously please remember that a1, b1, these are your coefficients of x and y respectively. c1 and c2 of course is the constant term, so they will not have any variable, so this is a constant term. There is a case, so case number 1, let me take two equations randomly picking. 2x plus suppose 3y is equal to 6. Okay, this is equation number 1. Then I'm taking another equation 4x plus 6y that is equals to 12. Now obviously some peculiarities in this equation, and what are those peculiarities? The coefficient of x, if you see a1 by a2, and if you reduce it, you will get 1 by 2, that is exactly equal to the coefficient of b1 by b2, which in turn is equal to c1 by c2. What effectively I am saying is, for this particular case in which the coefficient of x is equal, or the ratio of the coefficient of terms of x is equal to the ratio of the coefficient of y is equal to the ratio of the constant terms, you would realize that this is in fact coinciding lines. So these are coinciding lines, and basically a line, suppose this is a line, and on it if you coincide another line, so suppose this is that another line which you are coinciding, so how many solutions will you get for these two lines? And please understand, the line will extend till infinity, so obviously there will be infinite solutions, right? Infinite solutions. And that is why we call, if this condition is met, a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2, typically there are infinite solution. But exactly what is it that I am doing? I'm not trying to rectify anything, I'm trying to understand the idea, and the idea is pretty simple. They are coinciding lines, right? And because they are coinciding lines, this thing happens. Okay, so infinite solutions. Let's look into another case. Same equations, let's take the same equation, 2x plus 3y equals to 6, but this time around 4x plus 6y that is equals to 18. Now obviously you would have realized that a1 by a2 is equal to b1 by b2, but this is not equal to c1 by c2. Now obviously because the coefficient of x and y are equal, these are parallel lines. Obviously these are parallel lines, and the constant term can only determine whether the lines coincide or they are parallel, otherwise they will intersect. Okay, so the idea is pretty clear. They are parallel lines. You may wish to remember it like this. And how many solutions can we get for parallel lines? The answer to that is no solutions. Does this make sense? And I really hope it does. Okay, let's go to the last one. I am only discussing this because this is important, because there have been questions around this in the CAT also, and I'll show you. Same thing, 2x plus 3y is equal to 6. Taking a slightly different type of an equation just to explain a point. 3x plus, let's say, 4y, that is equals to 12. Now, if you realize, the coefficient of x, the ratios of the coefficient of x is not equal to the ratios of the coefficient of this thing, y. And obviously you don't really even have to talk about the other one, because the first two are important, that the coefficient of x and y basically determine whether the lines are coinciding, parallel, or the next one is whether they are intersecting line. Okay, now do we know what intersecting lines mean? Yeah, so the lines will intersect, something like this. And obviously two lines, any which ways they intersect, there is only one solution or one intersecting point, one solution that can happen. Now please remember this as a property, because this is something that you have to remember for your basic linear equations, because these are the type of question, I mean, there have been questions which uses this idea. There is a question in this slide also, which I will come to in a while, so just pay attention. Okay, so let's go to the next part, which is, now let us discuss something called integer solutions. Okay, now this is very interesting, because CAT will only ask you about integer solution. All those solving equations simultaneously and all that is not going to be tested. Specifically if you're taking CAT. I mean, if you're taking some other bank PO type exam, I am not sure, but for CAT you will only be asked to calculate integer solutions. Now please understand, what do we understand what integer is? Obviously we know integers. The collection of positive and negative numbers are integers. So there are negative numbers, -1, -2, -3, these are negative integers. And then there are positive integers, +1, +2, +3. Okay, what about 0? Come on, tell me. You can pause the video and go to Google to answer that question, but this is something that you have to keep in mind. 0 is neither positive nor negative. It is something similar to what we have studied in number system. Obviously you guys have not got the recordings yet. Numbers mein there is an idea that 1 is not prime, not composite. So neither prime nor composite, because the idea of prime factorization will get disturbed by this thing 1. So this is just an idea. Okay, this is just an idea that 1 is neither prime nor composite, is similar to the idea which we are going to use in this one, which is 0 is not a neither positive nor negative. Now typically understand, there is a lingo that CAT uses. Seldom you are going to get the language of positive integers, negative integers. CAT like to use a lingo like non-negative integral solutions. Okay, non-negative integral solution is also similar to saying that when we consider the set of answers, 0 will be added, and anything left of 0, that is -1, -2, these will not get added, and anything towards the RHS of 0, which is 1, 2, and anything like that, +1, +2, okay, these will get added. So this lingo, non-negative integral solution, non-negative will include 0, but if you are just asked integer solution, that will have to, I mean, integer solution will have infinite integer solution if they do not specify whether it is a positive integer solution that they are looking at, or they are looking at negative integer solutions. Okay, having said that, let's understand a few ideas about integer solutions. So let us take an equation. Okay, let's take an equation like 7x plus 114, correct? Now if you typically look into this equation, you'll realize two things, okay, and you'd have to be really fast to gather those things. First up, be very quick to analyze whether the equation is a increasing one or a decreasing. So the first task is obviously going to be whether it is an increasing or a decreasing. Now obviously, by our previous ideas that I discussed in the previous this thing, so you would have realized that this is a decreasing line because this is of the form ax plus by is equal to c. All right, it is similar to the idea of quadratic equations. When a quadratic equation, so ax square plus bx plus c, obviously I have not taught you this thing, but I'm just giving you as an idea because obviously I don't need to teach you anything. You guys already know a lot many things. I'm just reiterating those ideas, or I'm just reminding you of those things. Okay, so you guys are grown-ups, you guys have done graduation, so I'm not here to teach you anything. So we look at the coefficient of x square, and if it is a positive coefficient, that means it's an upward parabola. If it is a negative, then we conclude that it is a downward parabola. Okay, an upward and downward parabola basically gives identity to this thing, quadratic function or quadratic equation, whatever you want to call it. Okay, now for our purposes, we're looking at integer solutions for linear equations right now. So let us look into this equation, and let's try to draw some inferences through this equation. So the first one, if I were to ask you that you have to give me the solution pair, okay, and let me make your life a little easier. Give me the positive integer solution pair, positive integer solution pair that basically satisfies this equation. Now obviously, just pay attention to one thing. This coefficient is a multiple of 3. There is already a term in the equation which is a multiple of, so y is a multiple of 3. So this term has to be a multiple of 3 also, because adding these two I am getting this one, so obviously this one has to be an odd number. Again, I don't want to get into details because otherwise I'll have to teach you number system also, but please pay attention. You will not be very far behind. You can just pause the video and think about it, whether this 7x can be anything other than odd. If you can pause and ponder on it, nothing like it. But for the time being, let's begin. So a simple thing that comes into my mind is, how do I calculate the first? So I told you that the first thing that should come to your mind is whether it is an increasing decreasing line, and the second thing should be the first solution. Now typically the first solution will not be that difficult for you to calculate, because just now I said that because this is a multiple of 3, this already is a multiple of 3, the first thing that should come to your mind is substitute 0 for x. When you substitute 0 for x, y will come out as 38. Okay, this is going to be the first solution pair. This is going to be the first solution pair. How many more solutions pair can we get? We can practically get infinite solution pairs. And how, I will tell you. Now the next solution pair will be 3 and 31. The next solution pair will be 6 and 24. The next will be 9 and 17. Obviously, I'm not doing it from my memory. The next one will be 12 and 10. Now, how is it that I'm able to write these numbers so quickly? Obviously, if you have a knack for, numbers, you'd realize one thing, that obviously these numbers are increasing. These numbers are either increasing or decreasing, and this increasing decreasing I have already explained in the last part. Because this is a decreasing line, if the value of x increase, the value of y will decrease, and the decrement will happen in the coefficient of, so for this one the increment will happen in the coefficient of y. So basically this increases by 3 and this one will decrease by 7, and this will happen for every equation that you encounter. I mean, I'm not saying that it will increase by 3 and 7 only. I'm saying that the increment or decrement in the case of a decreasing line will always happen in the coefficient of the other term. So if you realize the next solution is, how do I know that the next solution is 331? Because 0 will get added, 3 will get added to 0, it will become 3, and 7 will get reduced or subtracted from this 38 to give me this one. Now if you notice, I have stopped at this point. Now I had asked you something. I had asked you ki how many integer solution, positive integer solutions are available to this solution. Now is it 1 2 3 4 5 6? Is it 6 or 5? Actually, if you go a little low, you will realize that this thing will go into the negative domain. This will keep on increasing, so this will become 18, but when you subtract minus 7 from this, what do you get? So 3 goes, this will become minus 4. Okay. So obviously this is not, so this is not some, 7 to ho hi nahi sakta. 7 is not possible because this is not positive integer now. This is going into the domain of negative integers, not allowed. If you allow negative integers also, then we are in a bit of a mess. I just now explained that 0 is neither positive nor negative. So if we had given you the idea that tell me non-negative integer solutions, then it would have been 6. But right now I have said positive integer solution, and that is why it is only 5. Okay. Does that make sense? I hope it does. Okay. Now, this is an interesting bit. Let's move beyond this. Okay. So what do we do next? Now let's take another equation. Okay. Let's take a case of a increasing line, let's say. So let me say an equation like 7x minus 31 that is equals to 1. Okay. Now, what is the algorithm that we follow? Identify whether the equation is an increasing or decreasing. Okay. The second one is, once you identified whether it is an increasing, decreasing, the second is quickly determine the first solution. And this will not take you more than 10, 15, 20 seconds. The first one is going to be generally very easy. Now I will tell you in a very atypical example like this one, if you have a 7x minus 3y is equal to 1, the first thing that you can do is you can substitute, you can transpose this 3y to the RHS, and you can get something like this. So 3y plus 1. Now work with the term which has a heavier coefficient that will make your life easier. So typically what do we do? I'll try to figure out the first, this thing. Substitute for x. If you substitute x as 1, this is 7 transpose y, this becomes 6, and y will come out to be 2. Did you understood what I did? I just substituted the value of x, and with the help of that substitution I was able to get the value of y. This is my first solution. Now this first solution is relative. Obviously, if you go a little back, you can trace. Now please understand that this is a increasing this thing. So typically x will also increase, y will also increase, and if x decreases, y will also decrease. So an x and y will always increase and decrease in the coefficient of the other term. So basically this will increase in the steps of 3. So 1 plus 3 is 4. Okay, so this is going to be 4, and this is going to be 2 plus 7, that is 9. So this is my second equation. Can you tell me the third one? Can you tell me the third solution? Be quick, guys. 7, 16, 10, 23, and so on and so forth. Now how about if I tell me for how many okay, so I'm asking you the question, find how many positive integer solutions exist for this equation such that x is less than equals 100. Now obviously you can see that because you know this one is increasing in the steps of 3, one thing that you should ideally observe, that this is increment of 333, and you have to be really quick enough to visualize that this increment is of the form 3k plus 1. Okay, now this will make your life really easy. Okay, if you substitute k as 0, this will become 1. If you substitute k as 1, this will become 4, which is the second solution, and so on and so forth. This thing you have to tell me less than equals 100. Now obviously this is 3k less than equals 99, k is less than equals 33. Now 1 all the way till 33. 1 all the way till 33. Is it 1 or is it 0? You have to be careful, because we did not started from this one. What we started from was k is equal to 0 we started, and we went all the way till k is equal to 33. We cannot go any further, so please do not get bogged down by this number 1. So this is from 0 to 33, 0 to 33, and thus we will have 34 terms, or 34 solution pairs also, you can say solution pairs. Now I know for a fact that there are going to be a few students who can say कि सर आप directly 100/3 करके भी तो ला सकते थे, और फिर आपको बस ये चेक करना होता. वो we will do it in the next phase. Okay, one thing at a time. This technique is for the 95 plus percentilers. Okay, ये typically ये 95 plus, एक्चुअली 95 भी नहीं है, 99th परसेंटाइलर्स के चोंचले होते हैं, जहाँ पे दे वांट टू एक्चुअली डिवाइड बाय द नंबर एंड वांट टू गेट एट दिस. बट इसमें कैविएट है, देयर इज अ प्रॉब्लम. आपको यू हैव टू बी स्पेसिफिक. इफ यू आर नॉट स्पेसिफिक यू कैन गेट रॉन्ग, बिकॉज एक या दो टर्म के वजह से आपका पूरा you could get the entire counting scheme wrong. So there is a caveat in this thing. If it is an easy equation, you can definitely do it 100 by this thing, and all you need to check whether we started from 1 or 0. If you are smart enough and you can see that we started from 0, obviously you will end up with 34 and not 33. But if you're not smart enough, you'll just mark 33, and that is not the answer. Okay, now give me a second. Okay, so we are back. We are looking at equation that involves, now linear equation without two variables is too stupid. anytime you're gonna get a equation that is linear will always comprise of two variables, but there are cases when you can have equations that involve three variables. Okay, and typically this will happen. There are CAT questions also on this one. So basically what I'm trying to say is the variables will be x, y and z. To get individual values, and you have been taught this thing in your junior classes, in your school, this thing, that typically to individually find the values of x, y and z, you need three equations. Three equations you need, and only then you can pinpoint the value of x, y and z. And this is pretty obvious, because obviously the equations, when you solve them, you'll get the values of x, y and z. For CAT, however, you don't need sometimes the individualistic values of x, y and z. Typically what CAT asks you, typically I'm saying, okay, this is again coming from the knowledge of the previous questions, the previous year question, whatever CAT has asked, and my experience. So typically what CAT asks, even if it gives you three variables, either they will ask you the summation of the three variables that is reducible to some extent. So suppose there is an equation like an x plus 2y plus 3z is equal to, let's say, 24. And then there is another equation. Suppose there is another equation which is given to you like 2x plus 3y plus 4z, that is equals to 30. And typically what they will do is they're going to ask you what is the value of these summation of the three terms, or the three variables rather, x plus y plus z. Typically they ask this thing only. But I mean, if they're hell-bent on asking you the individual values of x, y and z and only giving you this thing, then you have to work around, and you have to realize that one way or the other the equations will transform, or they'll get equal, or maybe x and y will have a relation. What is it that I'm trying to tell you? Please pay attention to this. If x and y have a relation, suppose x is equal to 2y, this is given. Typically this is this will never be given in this form, so they will always be like x is to y, 1 is to 2, or like something of this sort, right? So when x and y have a relation, the entire three variable nonsense is going to get broken down to just two variables. So basically x can be reduced to 2y plus 2y plus 3z is equal to 24. So this basically is 4y plus 3z is equal to 24, and this thing again gets broken. So this is 4y, right? Yeah, so this is 4y plus 3y, that is plus 4z, that is equals to 30. I'm just digressing, guys, so don't worry. So this is 8y plus how much? So this is going to be 4y plus 3z equal to this thing, and this is going to be 7y plus 4z. So 4y plus 3z is equal to 24, and this is going to be 7y plus 4z, that is equals to 30. Now can you please understand that now you can just reduce one of the variables, I mean do your elimination or whatever, you can get the values of y and z, and the moment you get the value of y, you can get the value of x, because there's a relation between x and y. So this is typically what CAT do in terms of finding equations. Is not something that CAT will ask you, so you know, we don't really need to worry too much about that. All right, so let's go to the questions now. Okay, so I hope you can see this thing. The question is very interesting question. Talks about what is the value of k for which the following system of equations has no solution. Now please understand, no solution ka I have already given you this thing. Just now we discussed for no solution there is an idea, and that idea is that the coefficient of, can you see this? Okay, let me use a different color. The coefficient of x is going to be, so basically we are talking about parallel lines. Okay, we are talking about parallel lines, and only parallel lines have no solutions. If you just remember now, three lines, there are only three types of line: coinciding line, parallel lines, and intersecting lines. Coinciding lines will have infinite solution, parallel lines will have no solutions, and intersecting line will of course have one solution. So this is a case of a parallel line, and this is a question from CAT 1991. If you pay attention, this is a CAT question. So back in the day, they used to ask question like this. Now all I need to do is, I will not do this, I will not write even a1 by a2 is equal to b1 by b2. I will not write this, just to explain things to you, I'm writing it down. Okay, and now you will just put the values. That is equal to minus 8 by 4. So basically k is equal to minus 1. Now this is the answer. So whichever has the negative one is going to be the answer. Okay, let's go to the next one. Interesting question. It says John bought 5 mangoes and 10 oranges together for 40 rupees. So can we form an equation? Again, a CAT 1993 equation, a good question. 1993 matlab ki not very, actually this is a long time back. So yeah, so basically 5 mango 10 oranges, I can easily do the equation. I can substitute 5x and 10y for 40 rupees. Okay, and the next part is that subsequently he returned 1 mango and 2 oranges in exchange. Okay, so if you realize, they have just given you one equation and an idea that he returned 1 mango for 2 oranges. So 1 mango is actually equivalent to 2 oranges. Exactly what I was saying, that either they will give you the value or they will give you a relation between the two variables. In this case, they are giving you a relation, which is the value of the mango is twice the value of this thing orange, right? So basically what you can do is, you can substitute for x in this equation only, and you will get 10x plus 10y, not 10x, 10y, because you know x is 2y, so 5x is 10y, so 10y is equal to 40. Now I am just doing it on paper, but this is pretty oral question. 20y is equal to 40, but I'm just trying to show you the idea. They have asked you the price for an orange, which is 2 rupees. Okay, option B is going to be the answer. And you can see that I am building the questions slowly so that you can pick certain ideas clearly. Let's go to the next one. Okay, an interesting question. The question is from CAT 1997, a good question. Okay, a typical, you can say, conceptual question. A student, instead of finding 7 by 8 of a number, finds out the value of 7 by 18 of the number, if his answer differed from the actual one by 770. So there is this thing, tell the number or give the number. So if you realize there is no two variables, a single variable, so I could just eliminate 7 from both end and I will get this thing. The next part is pretty intuitive. This is going to be 18x minus 8x, that is equal to 110 into 18 into 8. This is equal to 10x, that is equals to 110 into 18 into 8. 0 and 0 cancel. Now x is equal to 11 into 18 into 8. Now this is very, you know, this thing, 11 times 18. How do I do 11 times 18? It's actually 180 plus 18, 198. So 198 into 8. So there are many ways of doing this. Typically I'm just showing you how you should do it. This 198 can be broken as 100 plus 90 plus 8. Just multiply individually these, so you'll get 800. All of this will be in your mind. I'm doing it in the whiteboard because I want to show you something, but all of this can be done in your mind. So 800 plus 720, you do this in your mind. So this is 1500 and this thing, and the last bit is 64. I don't even have to do anything. I have a option with the last letter as 4, but still let's do it. So 4, 8, and this gives me 15. So 1584 is the number which I was supposed to find out. So this is this is something that you can do in your exam. Okay, let's go to the next question, shall we? Okay, this one is an interesting one. Let's do this one. This is the last. Let's do this as the last question, because the number of positive integer valued pair satisfying 4x minus 17y. I will write this. I will definitely not write it in an exam condition. And x has to be less than equals to 1000. Okay. Sorry. Okay. Typical question, 4x minus 70y. Obviously, two things, I will not write it, but two things you have to put in your mind. That first up is increasing line, which means both the values of x and y will increase or decrease, whichever is the case. Now I will give you a very intuitive way of solving this one. I have said always that whenever you encounter such a problem, you should what you should do is always consider it like this. Okay, now obviously work with this big number, because that will give you easier terms, and this will be much more easier to work with 17y. Coefficient is a little large, but nevertheless, if you substitute 1, this will become 18, so 1 does not satisfy. If you substitute y as 2, this is 34, and 135 does not satisfy, because 35 will not get eliminated by 4, or 4 is not a factor of 35. If you substitute 3, which is 30 and 21, 51, 52 is a factor. So typically this is going to be 3, and this one 52 is 13 if I'm not mistaken. Yeah, 40 and 12, yeah, 52. So I have received the first solution pair. Now, just as I said that the first solution pair is not going to be very difficult for you to calculate, it is actually going to be very easy. Now, either you increase or you decrease. Now obviously we want x to increase. We can decrease this also, because this will decrease in the steps of 17. That is also fine, but the question is asking us positive integer values, or the solution pairs should be less than equal to 1000. Now please understand that x needs to go till 1000 for that to happen, and obviously 17 will get added. So when 17 gets added to 13, you typically get a 29, and the next number again when 17 gets added, so this is 39 plus 7 is 46, and for this one this gets added, so this is 7, 11. Typically I don't care about this part, because yeah, so 17, right? If you pay attention, this is again I am using the same idea, 17k, and you have to be a little quick. So 17k minus 4, if you see 17, if you substitute k equal to 0, you'll get 17 minus, or rather 17k cannot be equal to 0, so k will start from 1. For 0 it will not satisfy. For this thing, for 1 it will be 13. So for k equal to 1, we have to go all the way till 1000. Okay, you have to remember that thing. This is actually 1004, 17k. So k has to be less than equals to 1004 and 17. So basically, if you pay attention now, this is exactly what students do. This is what students should do. Typically a student will do this. Typically a student, a half-baked mind, I would call them, will do this thing. Okay. 17, I have to divide 17 by, rather I have to divide 1004 by 17. Now obviously there are many ways to do it. Actually, if you look around, na 17 6, this is 104. sorry, 102. So this is 17 6 1760 is a 6 102, 1760 is a 1020. So 1759 will be how much? 1759 will be 17 less than this, which will be 1003. Now the question has asked me that it has to be less than 1004, and 59th term is giving me 1003. Now you have to tell me, typically a student will, you know, the 1000 divided by 17, the students that will do 1000 by 17 will end up at 58, but the correct answer is actually 59, it is not 58. So now that this is exactly how cat, you know, irritates you. It will ask you one thing and the answer you will get an exactly different thing. So actually the answer to this is going to be 59. Okay, an interesting one. Whenever you have to pay attention, you cannot say ki sir मैंने 15-20 सवाल कर लिए ना, now I will do only 1000 by 17. Please pay attention to this part. If you are very quick, I am very happy that you are very quick and you can do all of this and quickly you can understand. But again, you have to, this thinking process needs to be in place. This thinking process that 176 is 102 and then 1760 is 1020, 1020. So 1759 में check करते हैं. 59 will be 1003. 1003 is less than 1004, and my idea was that I was supposed to get something less than equal to 1004, and that came out because of this equation. The transformation of the equation was important. Otherwise, if you would have just divided 1000 by 17, you would have gotten 58, which is not the answer. Please verify this question. Please do this question again and again. This is a CAT 1999 question, so you will get it in the public domain. And if you're not able to understand what I'm trying to teach you, if you understand, a great thing. Let me see if we have time left. So, okay, I'm not going to do this one. Okay, this is a good one. Let's do this for the last question. Okay, do we have any more questions? Yeah, we have quite many questions. Okay, let's do one more and then the rest I will do in a separate session. So let's do this one. I will read this one out for you. 3 friends returning from a movie stopped to eat at a restaurant. After dinner, they paid their bills and noticed a bowl of mints at the front counter. Sita took 1/3 of the mints but returned 4 because she had the momentary pang of guilt. She took 1/3 of the mints. So Sita took 1/3 and then she returned how many? 4. She returned 4, right? Fatima took 1/4. Fatima took 1/4 of what was left but returned 3 for the similar reason. So what was left and then returned 3. Ishwari took half of the remainder. So whatever was the, Ishwari took half of the remainder but threw 2 back into the bowl. Now this is a typical way of solving this thing, but I will give you the idea, and the idea is pretty simple. Look at the options. There is only 2 ways of solving this question, and these type of question come in CAT again and again, and the only way to solve such question is through the options. And if there are no options, then you can obviously backtrace. If you have to substitute values, if you form equation x, y, z, I'm afraid to tell you that you may be preparing for an exam that I am not teaching. If you have to form equations and solve this, it will take you somewhere around 5 minutes. Look at this. The question says this girl Sita took 1/3 one third. So suppose, you know, many candies were there and she basically took one third of this and then returned 4 back. Please tell me, if there were 90 candies, how many did she took? She took 30. And you know, after that she returned 4 back, so she has 26 with her. But this means one thing, that the bowl has to have the number of candies which will be a multiple of 3. Can you see that any of the options as a multiple of 3? So the answer to this is none of these. It can be solved, and I will solve this in the next session. So this is it for this session. I will come again. And guys, there is a initiative that is going on in the description. There I am going to give you the link. Please check out the description. One more thing, I am giving you guys a homework, and that homework is that try out this question, rather, you know, try out this question. So okay, just a second. Try out this as your homework. So I'm giving this as homework. I will of course solve this as well. I will solve this also, but in the next session. So algebra 102, I will solve this, and I will also give you some more information. In the next session, we will learn graph theory. So the next session will be on graph theory. Graph theory is very simple. This will talk about different type of graphs for linear, quadratic, and cubic equations, and how we can interpret graphs, how we can use the graphs to answer questions easily instead of, you know, falling into the traps of solving equations unnecessarily. So this is me, Somajit Kushwani. That is all from my side in this video. Thank you very much, and I hope you enjoyed this session.